Hello guys, my name is Hitesh and in this video we're going to be discussing about sets. So the textbook which I'm using for reference here is Ncert textbook of 11th standard mathematics. So I'll put the link in the description so you can download it for free. So let's try to understand the concept of sets. So the definition of set is a set is a well-defined collection of objects. A well-defined collection of objects. Now the well-defined should be proper. So what they're trying to say is you have to make sure the set makes sense for everyone, or else the set what we're trying to make should be universal for everyone. For example, if I say the set of all the planets across the solar system, now this is a well-defined set because this doesn't change from person to person. The idea doesn't change from person to person. So I can say that the set of all the planets across the solar system is a well-defined set. Now at the same time, if I say set of all the great batsmen in India, now that is not a well-defined set because the concept of best batsman varies from person to person. So because of that, I can't say that is a set because it is not well defined. So you have to make sure that the opinion or the statement which you're trying to make, it's universal, it's agreeable by everyone. So that is a well defined collection of objects or a set. So let us try to solve exercise problem on this concept so that we can have a further understanding of this. So I'm going to solve the exercise 1.1 problem number 1, and that's sub point 1. So which of the following are sets? Justify your answer. So the first one is collection of all the months beginning with the letter J. Now if you say collection of all the months beginning with the letter J, what are all the months which is beginning with the letter J? It is January, July and June. January, June and July. Now does this opinion changes from person to person? No, it doesn't change from person to person. If you're going to ask any educated person of all the months which is starting with the letter J, they're going to say only these three objects. So I can say this statement is a well-defined collection of objects. Hence, the first one is a set. So the next one is the collection of most talented writers of India. Now, as I told you before, if the statement varies from person to person, then you can't say it is a well-defined statement or not a set. Now the question is the collection of most talented writers in India. Now the talent is a subjective thing. It changes from person to person. Now, for one person, a talented writer might be a Rabindranath Tagore. For one person, it might be Munshi Premchand ji. So it varies from person to person. So because of that, I can't say the second problem as a, so it is not a set because it varies from person to person, or you can say it is not well defined. The third one is a team of 11 best cricket batsmen in the world. Now this is also not well defined statement because, as I told you, this statement varies from person to person. For one person, the best batsman could be Virat Kohli. For other person, it might be MS Dhoni. For another person, it might be Rohit Sharma. So this statement varies from person to person. So that's why I can say the third problem is not a well defined collection of objects. Hence, it is not a set. So the fourth one is collection of all the boys in your class. Now the collection of all the boys is fixed, and this statement doesn't change from person to person. So from this, I can say the collection of all the boys in your class is a set. So that's the statement, and that's the problem. Just observe the statement and see whether the statement is agreeable by everyone. If it is agreeable by everyone, which means it is a set or well-defined collection of objects. If it is not agreeable by everyone, if it is varying from person to person, it is not well-defined collection of objects. For example, if the most dangerous animal in the world, for me it could be a tiger or something. For my sister, it's a cockroach. So there you just saw it's not well defined. The perspective changes from person to person. So that's why I could say some statements are not well defined. Hence, they do not constitute for a set. So the next one is the collection of all the natural numbers less than 100. Now this is well defined. As you know, natural numbers are all the numbers which starts with 1, 2, 3, 4, and so on till infinity. So these are all the natural numbers, and the set says collection of all the numbers less than 100, which means the set is going to be 1, 2, 3, 4, 5, all the way up to 99. Less than 100, which means you should not include, if they're saying not to include 100, so 1 to 99. Now this is well defined, so I can say this is a set. So the next one is sixth one, collection of all the novels written by Munshi Premchand ji. So this is also a well-defined collection of objects because the collection of all the novels is fixed and doesn't change from person to person. It's not a subjective thing. So I can say the sixth one is a set. The next one is last one is not the last one. Seventh one, the collection of all even integers. Now this is also well defined, so it's also a set. Collection of all even integers. So integers are the one which are which is going to look like this. So minus infinity, you're going to come like this: minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. I'm going to discuss about all these numbers in a few moments. So let us now just understand this. So till infinity, they're saying a collection of all even integers, which means even integers which even, they're not saying positive integers, so I could also include negative ones. So minus 4, minus 6, so all the way to minus infinity. So all the even positive integers, sorry, negative integers, and also the positive ones, 6. So this is a well-defined collection of objects. Hence, I can say this statement is a set. And the next one is eighth one, collection of all the question in this chapter. So the collection of all the questions in this chapter is fixed and doesn't change from person to person, or it's not a subjective statement. So I can say the eighth one is a set. The collection of most dangerous animals in the world. So as I told you before, it's not a set because it changes from person to person. So now let us see how we can represent sets. So sets are normally denoted by capital letters, and the elements inside the sets are denoted using small letters. So sets are denoted using capital letters, and the elements, all the components, like if you say the planets, Mercury, Jupiter, you can use small letters to denote those. So those are called elements. So elements could be easily denoted by using small letters. So capital letters denote the set, and small letters to denote the elements. So now let us see different methods of representing a set. So the first method is rooster form, rooster slash tabular form. So in this method, in this representation, you're going to denote, as I told you, you're going to use capital letters to denote the set, and you're going to list every single element inside the set. For example, if I say set A equal to set of all the planets in the solar system, in the form of rooster form, it's going to be written as, so Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So all these will be written, like every single elements will be listed. So one thing you need to remember is you have to always use this flower bracket to represent the set. So you're going to use this flower brackets to bound the elements of the sets. You can't use other brackets like this or this. If you use this, they're going to cut marks, or they're not going to consider that as a set. So only use flower brackets to represent the set, and you just have to practice for some time. And even I was at the beginning wasn't able to write this. So as you keep practicing, you will be easily able to write this flower bracket. So you enclose uh, two flower brackets and then list all the elements in between that. So for example, if I say a set of all the vowels in the English alphabet, so it's going to be written like this. So set B equal to A, E, I, O, U. So this is how you represent in the form of rooster form. So this was the first form. Now let us see the next one. So the next method of representing a set is set builder form. So the second method of representing a set is set builder form. In this method, you're going to use a kind of a key, and you're going to use certain set steps in order to represent a huge set in a very short form. For example, now let us say, so the set is denoted as set of all the planets in the solar system. Set of all the planets in the solar system. And in the rooster form, you can write this as A equal to set of all x such that x is all the planets in the solar system. So this is like a defined rule which you need to follow. So how this is pronounced? So you're gonna call this as A equal. So A is set of all x. So this thing is set of all. Oh, so till here, set of all x, and you're gonna call this semicolon as such that. So this is going to be pronounced that A equals set of all x such that x is all the planets in the solar system. So this is how you're going to represent in the form of set builder form. Now in set builder form, you can compress a huge amount of set in a very small tiny amount. For example, let us say A is a set of all natural numbers less than 100. So you're going to represent in the set builder form as, so A equal to set of all x such that x, you can write like this in this way, or you can write in this way. So x belongs to natural number and x lies between 100 and 0. So there's one more thing which I included here, which is this. So this, you're going to pronounce this as belongs to. So this is set of all, and then x, set of all x, and this is such that. So A is a set of all x such that x belongs, so this you're going to pronounce this as belongs to. Belongs to basically means it goes to, like, it belongs to that set. So let me just write it out. So x belongs to n, and the range of x is between 0 and 100. So if you want to write this in Rooster form, it's going to look like something like this. So a equal to 1 2 3 4 5 6 7 8 all the way up to 99. Remember, 100 is not included till 99 it is. So they're saying less than 100, not less than or equal to 100. So you should make sure that's the thing there. So this is how we're going to write in Rooster form. This is how we're going to write in set builder form. So as you can see, in set builder it's a lot easier to write. Like, not, it's not easy, but if you practice, it's going to turn into easy. But still, if you can represent a very big set in a very short form. So that's the thing. So this is belongs to. So for example, a equal to a e i o u. If I say a belongs to a, which means small a belongs to this set, or if I can say I belongs to capital A. So that's how it is said. So it basically belongs to the short form of belongs to. So this is the so this is called as belongs to. So this was how you can represent sets. So now let us see some unique sets which are used in mathematics. In this chapter they're going to use a lot. So let us learn about that. So n is a short form of writing set of all natural numbers. So if you want to write this in Rooster form, you're going to write like this. So n equal to 1 2 3 4 5, so on. So the next one is z. Z is set of all integers. So this is going to look like, so z equal to, so minus infinity is going to come all the way from the number line. So you can imagine this is the number line. So minus infinity, 0 is somewhere in between. This is plus infinity. So 1 2 3 4 5, minus 1 minus 2 minus 3. So all the round off numbers. So it's going to something look like this. So on, minus 3 minus 2 minus 1 0, 1 2 3 4 5. So the next one is q, which is set of all rational numbers. Set of all rational numbers. So rational numbers are the one which could be represented in the form of fraction, where the denominator is not equal to 0. So I will write it in here. So numbers which could be expressed in the form of p by q, which is basically fraction, and q should not be equal to 0. You can't represent this in Rooster form because it's a very huge set. So you can represent this in a set builder form. You can write like this. So set of all x such that x belongs to q, or you can write, if you want to write in more professional way, you can write x equal to p by q, where q is not equal to 0. So you can write like this, where you can write p and q belongs to integers, if you want to be more precise. So this is how we want to write in set builder form. So this were the few sets, and the next one is real numbers. Set of all real numbers. So R represents the set of all real numbers. So real numbers include both rational and irrational numbers. So that's the one thing you need to remember. So the set of all real numbers. So if you don't know, real numbers is rational, which was this kind of numbers, plus irrational. So rational numbers are the one which could be represented in the form of p by q, whereas irrational, which couldn't be represented in the form of p by q. So in this, x could be written in the form of p by q, where q is not equal to 0, and p and q belongs to integers. Where in this case, you can't represent the x in the form of p by q, so not equal to, where q is not equal to 0 and p and q are integers. For example for this is, you guys probably know, pi, exponential value, so on. So these are rational numbers and these are rational numbers, and if you combine them, you're going to get real numbers as your huge set. So this was the set of all real numbers. You're going to use R for that denotion, q for set of all rational numbers, and n for set of all natural numbers, and z for set of all integers. And the next one, they use this, it's not written in the book, but still I'm going to tell it to you. W, set of all whole numbers. Set of all whole numbers. So whole numbers is basically 0 plus natural numbers. So natural number is the one which starts from 1 2 3 4 5 and still goes on. So if you want to get whole number, just add 0 and then you're going to have your whole numbers. So whole number is basically natural numbers plus 0. So that's it. So this was the basic introduction of how you can represent sets, and how we can, and all the different types of sets which are used in mathematics. So we saw all those. So let us see a few problems, and try to understand it in more detail. So now let us try to solve a problem. So I'm going to solve exercise 1.1 second main. So it says A is defined like this, and we have to include the appropriate symbols, belongs to or doesn't belongs to. So we're going to solve this. So does 5 belongs to A? Yes, 5 is in there. 5 is there in the A. So I'm going to write like this. So 5 belongs to A. Does 8 is there in the A? No, which means 8 doesn't belongs to A. Is 0 is in the A? No, which means A 0 doesn't belongs to A. So this is belongs to, this is does not belongs to. So make sure to keep that in mind. So 4, does 4 is in the A? Yes, 4 belongs to A. 2 is in the A? Yes, 2 belongs to A. This is 10 is in the A? No. So 10 doesn't belongs to A. So make sure this is belongs to. So this is does not belongs to or not belong to. So I'm going to solve the third main. So write the following sets in rooster form. So we are supposed to write this in the form of rooster form. It's given in the set builder form. We're supposed to write in rooster form. So the first one says A is the set of all x such that x is an integer and it belongs in between -3. So it's -3 less than or equal to x less than 7. So basically this means is, so just write in the number line. So here comes a 0 and somewhere 1, 2, so on. Here comes a 7. So -1, -2, -3. So they're saying x is equal to, less than or equal to, which means -3 is included. So I'm going to write a circle and I'm going to shade that. And next is 7, and 7 is not included, so there is no equal to sign here, so I should exclude 7. So this is the thing. So and then put a number line here and just include all the elements which are there in the number line. Oh, there are numbers here, 4, 5, 6. So that's didn't write. So just include the shaded part, shaded boundary, but don't include the non-shaded boundary. So that's the rule. So A is equal to -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, but not 7 because I've not shaded that on the 7. So if you shade, you should include that. If you don't shade, should not include. So this is the set of your first problem. So next problem is B is set of all x such that x is a natural numbers less than 6. So they're saying less than 6 but not equal to less than 6. So all the natural numbers less than 6. So natural numbers starts with 1, 2, 3, 4, 5 and so on, and which means, and they're saying it is less than 6. So 1, 2, 3, 4, 5. Let's stop with 5 because they're saying less than 6. So less than 6. So this is the first two problems. So the next one is C set of all x such that x is 2-digit number such that the sum of the digit is 8. So they are trying to give the clue. So the numbers are, so the elements are in such a way that there are two digits numbers. So the numbers, and if you add the digits, you should be getting your sum as 8. So basically, suppose you have say a b as your number, and if you add those two numbers, so two digits, so a plus b should give you 8. For example, so if I take 17, 1 plus 7 should give me 8 because 1 plus 7 is 8. So these are the type of numbers which I need to include in my sets. So first element is 17. So you need to just increase this by 1 and then decrease this by -1. So let's increase this by 1 and then decrease this by 1. So the basically trick is, as I told you, increase this by 1 and then decrease this by 1. So 26, 35, 44, 53, 62, then 71, and then 80. So these are all the numbers in which if you add the digits, you're going to get your sum as 8. So 1 plus 7 is 8, 2 plus 6 is 8, 3 plus 5 is 8, and so on. If you add every single numbers, you're going to get your answer as 8. So this is how you can use logic and try to solve the problem. So let me just try to erase this. So 17, 26, 35, 44, 54, 62, 71, and 80. So this is the answer. So the next one is D equal to set of all x such that x is a prime number and it's the divisor of 60. So x is a prime number and it's the divisor of 60. So let's try to find the factors of 60 first. So 60 equal to 30 into 2 or 30 into 10 into 2 or 30 into 5 into 2 into 2. So what are all the prime numbers in this? So what are all the prime numbers? So just have to split the numbers in this factors, and you can see from this you just have to write in the form of prime factors and then list all the numbers here. So D equal to 3, 5, 2. Just have to write once. If the number is repeated twice or any element is repeated twice, just have to include it once. So the fifth one, E is a set of all the letters in the word trigonometry. So let's try to list all the words which are there in the word trigonometry. So first is T R I G O N. So O is I've written already O, so I don't need to write it again. So make sure if anything repeated twice, you just have to make sure you write it once. So once is just enough. So N, and then M is not there, M. So E is not there, E. So T is already written, so I don't need to take T. Then R is already there, and then Y. So that's the set of all the words, set of all the letters in the word trigonometry. So the next one is set of all the letters in the word better. Try this, or I'll try. So F equal to, so B is not there, E, okay, T, and then T is already repeated, written once, so I don't need to repeat again. And then E is also written already once, so I don't need to repeat again. And then R. So in this problem, we're supposed to write all this rooster form in terms of set builder form. So the first one is 3, 6, 9, 12. So you might have seen, you can see a pattern here. So it's the first four multiples of 3. So you can write like this. So I'll name this as A. So A equal to set of all x such that x equal to 3n, and n is a natural number, and n lies between 4 and 1. So you can write in this way. So n is your natural. So 3, you put 1, you get 3. You put 2, you get 6. You put 3, you get 9, and you get 4. You put 4, you get 12. So I have included both 1 and 4. So there are many different ways to write this. So this is one of the way. So in which set of all x is that x is equal to 3n, n belongs to natural number, and it lies between 1 and 4, including 1 and 4. So the next one is 2, 4, 2, 4, 8, 16, 32, and so 32. So here you can see it's all powers of 2. So 2 power 1, this is basically 2 power 1. This is 2 power 2, or 2 square, 2 cube, and this is 2 power 4, and this is 2 power 5. So how you can write this in set builder form? So I'll name this as B. So B equal to set of all x such that x equal to 2 power n, where n belongs to natural number. So you need to make sure that you frame what type of number it belongs to. So n belongs to natural numbers, and n lies in between 5 and 1. So starting from 1, you put 1, you get 2, you put 2, you get 4, you put 3, you get 8, and so on till 32. So this is also kind of same. So here it's power of 5. So 5, this is basically 5 power 1, this is 5 power 2, or 5 square, this is 5 cube, and this is 5 power 4. So you're going to write this now. So try doing this. So instead of try solving this, I'm going to solve it anyway. But C equal to set of all x such that x equal to 5 power n, and n belongs to natural numbers, and n lies between 4 and 1. That's all. So just have to write in this way. So the next one is 2, 4, 6. It's easy. It's all positive even numbers. So you can write like this. So D equal to set of all x such that x is all positive natural even numbers. So positive natural even numbers. So this is one of the way of writing this, or else you can write like this also. Set of all x such that x equal to 2n, where n belongs to natural numbers. Just try to put this. Put n equal to 1, you're going to get 2. Put n equal to 2, you're going to get 4. Put n equal to 3, you're going to get 6. So there are many different ways of representing in the form of set builder. So you can choose whatever seems to be easy to you. So you can write this or in this way. So the next one is it's 1, 4, 9 all the way up to 100. Now if you see this suddenly, you might not get the idea of what pattern is there here. So as you solve, you're gonna get the idea. But in the beginning, if you are feeling confused, it's not perfectly normal, no problem. So let me try to explain you this. So this is actually the perfect squares. So this is basically 1 square, and this is 2 square, 3 square, up to so on till 10 square. So let us try to write this in set builder form. So we're going to use mathematical way. So this is E. So E equal to set of all x such that x equal to n square. I'm going to write it as n square, where n belongs to natural numbers, and n varies between 10 and 1. Try this. Put n equal to 1. Put n equal to 1 here. We're gonna get our answer as 4. Put n equal to 2, 4. Put n equal to 3, 9. Put n equal to 10, 100. So this is just belong. You can say 1, 4, 9, so on till 100. So this is how you say this. So you can't write all the elements, no. So simply they just try to write in the compressed form. So just need to understand how it is. So what kind of pattern is there here? So this was the fourth main of exercise 1.1. Let us try to solve the next one, fifth main. So the first problem is written over here. So we have to write this in the form of rooster form. So the given is, it's given in set builder form. So a equal to set of all x. It's that x is a odd natural numbers. So odd natural numbers. So it's going to be right something like this. So 1, 3, 5, 7, 9, so on. They're saying natural numbers, so I need to take from the natural number set itself. So 1, 3, 5, 7, 9, and so on. So the next one is b equal to set of all x such that x belongs to integers, and the x lies between minus half to uh, 9 by 2, excluding half, minus half, and 9 by 2. So if you are confused with these kind of problems, so the best way of solving this is using number lines, as I told you before. So just try to write the number in the form of number line. So I'll solve this here. So half 9 by 2. So this is basically, half is just basically 0.5, or 0.5 minus 0.5, and this is basically 4.5. So here x is between minus 0.5 to 4.5. So if you write this in number line, so this is a number line, so this is 0, so this is 1, 2, 1, 2, 3, 4, 5, and here in this side minus 1, minus 2, minus 3, so on. So where does your 0.5 minus 0.5 come? Here. So here is your minus 0.5. Where is your 4.5 comes? Here. So this is your 4.5. So what as I told you, what are you going to do? You just have to write the limits like two circles in the boundaries. So these are the boundaries. So write those above the numbers. That's the first step. And then if you have equal to, circle, shade this, which means you have to include that. If nothing is there, you don't need to shade that. So in this case, it's not there, so don't shade that, which means you should not include that. So here also it's not there, so I don't shade there. Then write the number line, write the line, and then include all the elements which is there in between these two. So the elements which are there here is 0, 1, 2, 3, and 4. So this is how you solve these kind of problems. If you're confused, just write in the, so convert fraction in the form of numbers, and then write in the number line, and then represent in the number line. Write this kind of thing, and then easily it will be able to solve. It will be able to solve. So that's the next thing. So next problem is set of all the letters in the word loyal. So try to solve this. It's very easy. So answer is LOYA. I'm not going to write L again because I already wrote it. I've already written it. So as I told you before, you don't repeat you don't repeat elements. So it's already, if it's written once, it's enough. So I think I missed out the third problem. So I'm going to solve that here. So C equal to set of all x such that x belongs to integers and x square is less than or equal to 4. So how are we going to solve this? So just write it aside. So x square is equal to 4, and if you take the square that side, you're going to get plus or minus root 4. Remember, plus or minus, not only plus. So x equal to plus or minus 2, which means your range is somewhere between minus 2 to plus 2, including those two numbers. So if I want to write in number line, it's going to look something like this. So 1, 2, 3, minus 1, minus 2, minus 3. So starting from 2, minus 2, and then 2, and then equal to sign is there. So I need to include these two numbers, and then write the number line. So my C equal to minus 2, minus 1, 0, 1, 2. So this is my set. So the how to solve this will be learned in linear inequalities. So you don't need to worry about that right now. Just let me explain this in an easy word. So this is how it is. So if you have plus, the inequality remains same. If you have minus, so in one case you have plus 2, and in one case you have minus. So in that case you need to invert the sign. So that's why I wrote in that way. So in this case, I have to invert the sign, so it becomes something like this. So if you integrate these two, you're going to get something like this. So that's the rule which you're going to learn in linear inequalities. So for now, this is the rule. So if you have negative sign, you have to invert the inequality. If you have positive sign, you can keep it as it is. So that's why I wrote in this way. So that's how you solve the problem. And the last one is f equal to set of all x, so that x is a consonant in the English alphabet which precedes the k, which means it's behind the k. So let us write all the things. So a, b, c, d, e, f, g, h, I, j, k. They're saying preceding k, which means I should not include k. So k is not invited. So then they're saying consonant. Consonant means a, e, I, o, u, vowels minus, alphabets minus vowels. So we need to remove the vowels. So a is a vowel, so I remove that. Then e, then I. So apart from that, you can write all the elements in your set. So f equal to B, C, D, F, G, H, and J. So this is how your set F is going to be like. So this is the last main of the first exercise. So sixth main. So you have to match the following problems. So let us try to solve the. So we can do either solve this and match that, or solve that and match this. We're going to solve that because normally, or anything anyway, we're going to solve that and then match for this because that's way more easier. So first let us try to exclude all the easiest ones. So you can directly go for this. These two are directly linking. Set of all x is set of all x, as that x is a letter of in the word mathematics, and all the letters are included here. So M, A is there, T is there, H is there, E is there, and then M is there, A, T, and just match it, you'll get the answer. So this matches with this. And the next one, next easiest one is x is set of all x such that x is set of all x such x is a natural number, odd natural number and less than 10. So it's an odd natural number and is less than 10. So it's going to be 1, 3, 5, 7, 9. So it should be less than 10, uh, which means less than 10, and then all the natural numbers. So 1, 3, 5, 7, 9, which matches with this. So this goes with this. And the next one is set of all x such that x is a prime number and divisor of 6. So they're saying x is a prime number and it divides 6. So let us try to solve that. So you have 6, and what are the factors of 6? 2 and 3. So these are prime numbers, and then so if you want to write them in sets, it's going to be look like this. It's going to look like this. So 2, 3. So this matches with this. And the next one, and anyway, this one and the last one matches with this. We're going to confirm that again. So they're saying natural numbers which divide 6. So if prime number is given, you can easily write the factors and then figure it out, all the prime numbers. So if you have natural numbers, just do the trial and error. So you have 6. So what are all the numbers which divide 6? So 1 divides 6, 2 divides 6, 3, 4 doesn't divide, 5 doesn't divide, and then 6. So these are all the only numbers which divide 6, which means these are the answers. So this was the first exercise. The second exercise will be solved in the consecutive videos. So for that, hit that subscribe button and that notification bar so you don't miss out the next upcoming videos. So this was the end of the video. So I meet you in the next video. Thank you.